Okay, good morning. This video is for my ninth period class, but I'm going to put it on the fourth period thing as well. Just going over the last two problems on 4D part two, to just get us ready for our quiz in case you need a little extra practice or you need another thing here. Okay, um, so first here, we did the first problem together in class. I'm sort of just doing the last two. So we have four given things right here. FE and ED are perpendicular, so we have that. And we have CA and AB are perpendicular, so we have that. ED is congruent to AB, so we have ED and AB congruent to each other here and here. And we also have FC being congruent to DB down here, okay? And all we're trying to do is prove that these two yellow triangles are congruent to each other, okay? The two yellow triangles are congruent to each other. Um, so if we start with sort of the big picture in mind, we know we have right triangles right here because we have the right angle, and we know we have one of the legs congruent to each other, ED and AB. Okay, um, so with that, it could be maybe either side angle side, or it could be HL. Okay, because that's kind of what we have, side and angle right there, side and angle right there. So we have to determine, is it going to be a third side or is it going to be the hypotenuse and leg? Okay. Well, if it's side angle side, we're going to have to look with something with CA and FE. Okay. CA and FE. And we don't have anything regarding CA and FE. Okay. So that's probably going to be out. However, hypotenuse leg. Okay. So this triangle CAB has a hypotenuse of CB, and this triangle FED has a hypotenuse of FD, which I think we can kind of use. Okay, so that's where we're going to begin here. All right. So first thing in my thing is my given, and I'm just going to save space. I'm going to put all my given stuff right here. So all these four given things, we're going to put right there. Okay. We're going to do that. Okay. Next, just to take care of some other stuff here, we know that these are right angles. So, angle A and angle E are right angles. Okay, and that's by the definition of perpendicular. Okay, so whenever they tell us perpendicular, then we know that A and E are going to be right angles. Okay, and now, then since they're right angles, angle A is congruent to angle E, by, um, the right angle theorem there. We really don't even need that because it's a right triangle, but we'll just make sure that we have that just in case we may be needing it. Okay. Now, next, if we look at the hypotenuses here, um, both hypotenuses share CD. Okay, so if I'm looking at this hypotenuse FC, okay, well, FD, excuse me, FD has FC and CD, right? All right. The hypotenuse here from B to C has BD and CD. Okay. So we can maybe come do some angle addition here, or segment addition, excuse me. And we could say, FC plus CD equals FD. Okay. And we also know that DB plus CD equals BD. Okay. And that is segment addition. Okay, so we just know that this whole segment FD, the hypotenuse is FC plus CD, and we know that this hypotenuse here, BC, is equal to that should be BC. BC is equal to DB plus CD. Okay. So let me just clean this up just a little bit. All right. So what we know here is we know that both of these things have a CD in it. We also know that DB is equal to FC, so we can maybe substitute some of this out. Okay, so FC is equal to DB. So maybe we take FC out of here, and now we put, um, DB plus CD equals FD, right? And we know that DB plus CD equals BC, okay? And that's, we just substituted what we were given, okay? Okay, we substituted since FC and DB are the same. Okay, we'll substitute DB in for FC, okay? And now we see that all these things are equal, okay? So, DB plus CD equals FD and DB plus CD equals BC, okay? So, since all of these things are equal to each other, we know that FD is equal to BC. Okay, so that's sort of another, substitution right there. We didn't even need to subtract, which is kind of nice because we just added together this and those, and we see that the substitution makes them the same, okay? And so now the triangles are going to be congruent by hypotenuse leg, okay? And that's all they're asking us to prove is the triangles are congruent, okay? So long story short, guys, I know this is kind of funky, but if we go back to just what our most basic thing was, so we have right angles, so we have a right triangle here. We have legs congruent, AB and ED. And we should be able to see since FC and DB are congruent to each other, right? This hypotenuse FD has CD and then FC, and then the hypotenuse from B to C has the same length. We should see sort of before we even fill this proof table out that we're going to have a hypotenuse leg, okay? So, it's sort of just in here where we had to make sure we sort of put our proof as to why we can get our H's congruent together right there. Okay, so that should sort of help us out with that. And then the last one is a pretty simple one. Okay, so let me know if you have any questions on that. Okay, coming down here. And my fourth period class did a really good job sort of figuring this one out pretty quick, okay? What we're trying to prove is this angle SWT is congruent to angle UWT down here. And so we have all this stuff. So again, what I'm going to do is I'm going to take all this given stuff and we'll just put all the given stuff in the first box. Okay. Next, my fourth period class saw very wisely that I have two triangles here, RST and RUT, that share a side, RT right here, okay? So we could say that RT is congruent to the RT by the reflexive property. My writing's getting a little sloppy here. So RT is congruent to RT by the reflexive property, right? So that side is congruent to itself. And these two triangles, okay, are going to be congruent by side, side, side. Okay, so triangle RST is congruent to triangle RUT by side, side, side. All right, so that first part's pretty straightforward. Kudos to fourth period for figuring that thing out pretty quick. So we got these two triangles on the top and on the bottom congruent by side, side, side. Now, what my fourth period class so astutely saw is they saw, well, okay, we got the two big triangles congruent, but now what we got to do is now we have to work within these two triangles right there because the two angles that we have over here are the ones that we got to make congruent. So we have to go from these two big triangles on the top and bottom to these two triangles on the right, okay? And so how they saw first is they saw that, okay, these two big triangles, RST and RUT, and the two red triangles have this little angle in common right here and that little angle in common, okay? STW and UTW. Okay, so those angles STW and UTW are going to be congruent to each other by CP/CTC. Corresponding parts of congruent triangles are congruent. These two little green angles right here are congruent because they are corresponding parts of these two big orange triangles right here that we just proved congruent, RST and RUT. Okay, so that little green angle STW and that little green angle UTW are going to be congruent by that. Now, these two red triangles also share a side, WT. Okay, so we could say that WT is congruent to WT by the reflexive property again. And so now these two little red triangles are congruent, STW and UTW, by SAS. So we have side, two little green angles, side. Okay? So triangle STW is congruent to triangle UTW by side angle side, which makes SWT and UWT congruent by CP/CTC. So we didn't even use all of our boxes. So angle SWT is congruent to triangle UWT. Corresponding parts of congruent triangles are congruent, but now they're corresponding parts of these two little triangles right here. Okay, so that's 4D part 2 in a nutshell. Let me know if you have any questions before we do our quiz, and y'all take care.